we're continuing with part 2 of 6.3. We're going to pick up and start talking about common logarithms. A common logarithm is a logarithm with base 10. Okay? Well, I'm going to repeat that. A common logarithm is a logarithm with base 10. We write log base 10 of x simply as log x. So when you see a common logarithm, you will not see a base written, but the base will be understood to be 10. So we read log x as the logarithm with base 10 of x or log base 10 of x. All right? So anytime you see the word log and there's no base, you know that it is log base 10. So let's look at this problem here. They want us to, given the common logarithm of the form y equals log x, evaluate it mentally. So the first thing you're going to do is we're going to rewrite it. Anytime they ask you to solve a log mentally, it's helpful to rewrite it in exponential form and then see if you can figure out the answer. Okay, so we have y equals log base 10 of 1 million. I know that it is base 10 because there's no base written there. Okay, so that 10 is understood. So first I'm going to rewrite it as 10 to what power equals 1 million. And so 10s are easy when it is a number that is a 1 with several zeros, because all you have to do is count the zeros. 1, 2, 3, 4, 5, 6. So this is really 10 to the 6th power. So log of 1 million, log base 10 of 1 million equals 6. So let's try a couple more. Let's try log of 100. So log base 10 100. Log 1 over 10. Log 10,000. All right, so you see if you can do those mentally. See if you can figure out what the exponent for each of those would be, and then come back and unpause the video when you're ready to go over them. Okay, so for the first one, 10 to what power is 100? That would be 2. 10 squared is 100. The next one, 10 to what power is 1 over 10. This is where you need to remember about negative exponents. This would be 1 over 10 to the 1, which is the same as 10 to the negative 1. So the answer there is negative 1. And then here, 10 to what power is 10,000? So like count the zeros, 1, 2, 3, 4. It would be 4. Now, those are ones that we can do mentally, but we can't do everything mentally. What if we have this one here, log base 10 of 123? All right, so we can actually use the calculator for that. So in your calculator, you will have the log function. It says log, and that represents log base 10. So if they give you a log base 10, you can use the calculator to find it. You just hit the log button and then the number. So we're going to do log base 10 of 123, log base 10 of 123. So the log button is on the left column next to the 7, to the left of 7. So if you hit log, you'll see the word log comes up, and then we want 123. And that stands for log base 10 of 123. And what that means is, it means 10 to what power is 123. That's what it means. And 10 to 2.0899 is 123. is 123. So they wanted us to round to 4 decimal places. So that's 2.0899. Oops. And what that means is it means that 10 to the 2.0899 is 123. That's what it means. So I could say 2 carried to the 2.0899. Oops, not 2. I meant 10 to the 2.0899. And we get 122.99, which is 123 if you round. The reason that it's slightly off is because, well, let's just look what it was. Is because I rounded and I dropped off part of that answer. If I did 10 carried to the answer, second negative, we'll substitute the answer in. So I'm actually putting that number in as the exponent. You do get 123. So that's how you use the calculator. Now, again, the calculator is only good for log base 10. All right, so let's look at this application problem. It says the amount of energy released from one earthquake was 300 times greater than the amount of energy released from another. The equation, and then I had to write the equation down here. The equation 10 to the x equals 300 represents this situation, where x is the difference in magnitude on the Richter scale. To the nearest thousandths, what is the difference in magnitude? So the difference in magnitudes is x, so we need to solve for x. Now, look up here, it gives us a hint. It says rewriting and solving a real-world exponential model. So what we're going to do is we're going to rewrite in log form. And we do this because I have no idea 10 to what power is 300. I'm solving for x. You can't just get rid of the 10 on both sides. The x is kind of attached to it. So in order to solve this problem, we need to rewrite it in log form. So if I rewrote it in log form, I would write log base 10 of 300 equals the exponent, which is x. And I know that log base 10 of 300 is just log 300 in the calculator. So I'm just going to type in the calculator log 300. 2.477121255. They say to round to the nearest thousandths. So thousandths is 3 places, so 2.477. And that's all we do. Very quick. All right. So then we have common logarithms and then we have natural logarithms. Natural logarithms is log of base e. And so when we do a log base e, we write it as ln x, the natural logarithm. So it is equivalent to e to the y equals x. So when we see log base e of x, that's the same as saying ln of x. If we were converting it to exponential form, this would be e to some power equals x. So e to what power equals x. That's what it stands for. This is important to note. Y equals e to the x and y equals ln of x are inverse functions. This is important for later sections. Natural log of e to the x is x, and the reason is because if you think about this here, this is like saying e to what power equals e to the x. Well, that means this has to equal x, right? So that's why it equals x. To find natural logarithms, we just use the ln function on the calculator. It is in the left-hand column. So if you go to your calculator, you'll look on the left-hand side below log below log, to the left of -4, you'll see the ln button. So let's look at this example. It says evaluate y equals ln 300, or the natural log of 300, to 4 decimal places using the calculator. So we just type in ln 300, and that's it. 4 decimal places, 5.70378, so the 8 tells the 7 to become an 8, 5.7038. Okay, so now let's look back up here. It said that for y equals ln of x is equivalent to e to the y equals x for x is greater than 0. So let's look what happens when x is not greater than 0. This is like saying natural log of -500. It's like saying e to what power is -500. Now, if you will remember, when you take a number to a power, you can't get a negative number. Even if you take e to the 0, that's going to give you 1. If you take e to a negative number, that's going to give you a fraction, but it's not going to give you a negative number. So let's look what happens in the calculator when that happens. If we do natural log of -500, it says calculator error, non-real answer. For this last one, I would say it's undefined. All right, and I think that's all for this section, and if you have questions, let me know.